Let us move towards our next video. We are going to see Cramer's rule. This is your third method to find the solution of simultaneous equation. Till now we have seen elimination method, next graphical method. This is your third method, Cramer's rule. Now, yesterday we have seen how to find the value of determinant. This is going to help you to complete this Cramer's rule. Now, value of determinant. In this Cramer's rule, we are going to find D. D stands for determinant, dx and dy. Now, what are these dx and dy? Now, before that, let us go towards our standard form of linear equation in two variables. If you have forgotten, ax plus by is equal to c. This is your standard form of linear equation in two variables, where a is coefficient of x, b is coefficient of y, c is your constant. Now in similar way, this is your one equation. First equation, I have to tell you about second equation. So in the form of variables itself, using ABCD. So let us take this as A1, B1 and C1. And for second equation, we will write it as A2x plus B2y is equal to C2. So this is your first equation. This is your second equation. A1x plus B1y is equal to C1. A2x plus B2y is equal to C2. Where A1, B1, A1, A2, B1, B2, C1, C2 belong to real numbers. These are all real numbers. Now we have to find common solution for this simultaneous equation. So what is D now? D, determinant. D stands for coefficient of x and coefficient of y. That is A1, below that you are going to write A2, B1 and B2. Imagine this is your linear equation in two variables. For suppose A1 will be 5, 4, 3, 2, any number, minus 1, minus 2. In the similar way, B1, B2, A1, A2 and C1, C2. So this is your D. You're leaving constants. You're writing only A1, A2, B1, B2. This is your D. Now dx. For dx, leave this x variable and go for B1, B2, coefficient of y and constant C1, C2. But start writing from C1, C2. Don't start writing from C1, B1, B2. So C1, C2 comes first and then B1, B2. So this is your dx. Now comes dy. Obviously, what you will leave now? Y variable. And you will go for x and remaining one constant. So A1, A2. Now start from the first variable itself. A1, A2, x variable. And then go for C1, C2. Only for dx you are going to change the direction. You are going to start from constant. Elsewhere, no need of constants anywhere to start from constants. Only for dx. This is the way you are going to write d, dx and dy. But now you will say the solution of this simultaneous equation is to find x and y, because these are the roots of this equation. What are the roots of this equation? X and y are the roots. Roots in the sense, the solution for these two equations. So how to find x and y? Because in elimination method, in graphical method, at last what was your step to find x and y? Which were the roots of these two equations. Now how to find x and y? X will be dx upon d, ratio of dx to d, and y will be dy upon d. Means whatever will be the value of dx and d, dividing value of dx by d, you will get x. Similar way, you will get y. And this will be your solution for this simultaneous linear equation in two variables. Now let us go for an example so that you will understand it more properly. This was general explanation. I'm not going for solved example. I'm directly starting from your practice set 1.3, question number 3. First question, 3x minus 4y is equal to 10. This will be your first equation. I'm naming it immediately. 4x plus 3y is equal to 5. This is your second equation. So now Cramer's rule, by using Cramer's rule, first we will find D. What is your D? A1. This is your A1 now. This is your A2. Compare the equations. See, I am writing here again. A1x plus B1y is equal to C1. A2x plus B2y is equal to C2. Don't forget this thing. This is your general form, standard form of linear equation in two variables for Cramer's rule. So compare this first equation with this first equation. What is your A1? 3. What is your B1? -4. What is your C1? 10. Again for second equation, what is your A2? 4. B2? 3. C2? 5. If you're solving it for the first time, write this thing, general standard form of linear equation in two variables, on some another page, on rough page, and then write the value of D in this form first. Don't forget to write the value of D in this form. What is the form? A1, A2 first in first column and B1, B2 in second column. For D we are leaving constants. Okay, so this is your D. Now put the values of A1, A2, B1, B2. What is your A1? 3, A2 4, B is -4. Don't forget the sign. -4 and B2 is +3. So this is your D. I'm writing it here. Value of D, you are very well known about that. 3 into 3. Subtraction, -4 into 2. -4 into 4. Don't forget to give bracket. 3 into 3 first. 9 minus as it is. What is -4 into 4? -16. Don't forget to give minus sign, because plus minus becomes minus in multiplication. Now for this subtraction, what you will solve first? Signs are together, so solve it and write it. 9 plus 16. So this is 25. So this is your value of D. D is 25. Now next we will go for dx. I am not rubbing this standard form of linear equation into variables so that you will understand it more properly. Now dx. What is your dx first? Write it from here. What are you going to leave for dx? You are going to leave x variable. And you are going to start from C1, C2. So C1, C2, and then comes B1, B2. Now, so what is your dx? Leave x variable. What is your C1 here? 10. What is your C2 here? 5. B1 -4. B2 +3. Same way, cross multiplication. 10 into 3 minus -4 into 5. 10 3s are 30 minus as it is. -4 into 5 is -20. Two signs together, solve it and write it. So 30 plus 20. It is 50. So 50 is your dx. The same way you are going to find dy. What is your dy? You are going to leave for dy. You are going to leave y variable and start from x itself. A1, A2. Leave this thing. C1, C2. Okay, so dy is equal to, what is your A1? Compare this equation with this equations, 3 and 4. Leave y variable, 10 and 5. So this is 3 into 5 minus 10 into 4. 15 minus 40. Now 15 minus 40. 40 is greater number and the sign is minus for 40. So answer will be in minus. So this is minus 25. So dy is minus 25. Now we will go for a solution of this two simultaneous equation. What will be the solution now? Now no need of this general standard equation. What is your x? Dx upon d. What was your dx? 50. D was 25. So I'm putting the values. X is equal to, as it is, left hand side as it is, 50 divided by 25, 2. So your X is 2. Same way now, Y. What is your Y? dy upon d. What was your dy? Minus 25. And d was 25. Minus 25 divided by 25, minus 1. So y is minus 1. And this is the solution of your simultaneous linear equation in two variables. X is 2, y is minus 1. In this way, you are going to find the solution of simultaneous equation by using Cramer's rule. This was the first portion of your practice set 1.3. You are going to solve this sum itself for 3 times. Same way, the way I have solved it. And next 3 sums, you are going to do it for homework. Next 3 sums for homework.